All right, if we take a look at this one's pretty hard. There's a lot to this one. You're looking at properties of a kite. And specifically, as you go through and you look at these properties, to find the area, we really need to find the area of the triangles. Whether it's, you could break this into two triangles, you could find the area of all four triangles. It doesn't really matter how you do it. You could go through and find the area of this top triangle, GOL, and then find the area of the bottom triangle, GLD, that one, okay? Or you could find, like I said, each one of the four and then just add them all up, okay, either way. So if we take a look, there's two properties of a kite that you have to be aware of in order to do this problem. One of them is that the diagonals are perpendicular to each other. So you know that you've got all four of these are right triangles. Okay, that's one thing you have to be aware of. The other one, the other real main property of a kite is that the longer diagonal cuts the kite in half. Okay? So when I tell you that GL is 12, what that really means, if you wanted to think of it a different way, is that each part is 6. Okay? Not that you have to do it that way, but it'll help with some stuff that's coming up. Then I also told you that segment GD is 10, so there's that part of it. And I told you that this angle right here is 40 degrees. Okay? So, like I said, we can break this into multiple pieces. It doesn't really matter. I'm going to kind of break it into 4 triangles, and we'll go from there. So I'm going to focus specifically on triangle number 1 being right here. There's the first one. And then the other one I'm going to focus on is down below here. We'll go diagonal from that. Those 2 triangles. If I can find the area of those 2 triangles, then I already know I can easily then find the area of the whole thing because the triangles are just reflections of each other. Let's start with the bottom one because it's easier. In order to find the area of a triangle, remember it's base times height divided by 2. In this case, I have the base. It's right here. It's 6. What I'm looking for, I still need the height. Okay? I need this piece right here, the height. What is it? Yeah, this happens to be, because it's a right triangle, we can use Pythagorean theorem, and this happens to be one of your Pythagorean triples, if you remember. Okay? This is a 6, 8, 10 triangle. Okay? If you didn't remember, do the Pythagorean theorem, and you get 8. So now I've got enough information to find the area of that. We've got base times height, 6 times 8, 48, divided by 2. That means the area of this triangle is 24. Which means the area of the triangle right next to it is also 24, because those are just reflections of each other. Okay? So there's the bottom half of the kite right there. 6, 8, 10 triangles, find the area, and reflect. So now we move to the top one. Let's move to the red triangle up here. If we take a look at that triangle, we already have the base again. I've already got the 6. So once again, I need the height. Okay, this piece right here, I'm going to call it X. How do I find that? What do we do? Let's see. Lennon, I know you did it. How'd you find that?
I took the 12 times the 8 plus 5.03.
Where did the 5.03 come from?
I did tangent.
Okay? Yeah, if you take a look, again, right triangle. I don't know 2 side lengths, so I can't use Pythagorean theorem, but I do have an angle measure, so I can set up a trig type of problem. And in this case, the X and the 6 are the 2 legs, which means that's what makes it a tangent problem. So tangent of 40 degrees over 1 equal to X over 6. Opposite leg over adjacent leg. There's the setup to find X. And now we solve. Cross multiply, get X equal to 6 times the tangent of 40. And when you plug that into the calculator, you should get, what'd you say it was, Lennon? 5 point something?
Yeah, 5.03.
Okay. So the height of that triangle, use tangent to find it. And now it's 5.03. And now I've got enough information to find the area of each of those triangles. 6 times 5.03 divided by 2, and what do you get for, what is that? What's the area of each one of those triangles? Should be like 15 point something.
It's 15.9.
Okay. So 15.
No, wait, 15.09.
09. Okay, sounds good. 15.09 is, so there, that's what you should get for that triangle, which means again, that's the exact same area for the other one, 15.09. Okay? And now you've got the four areas. All you have left to do is put it all together. The area of this kite, we've got 24 and 24, that gives me 48. 15 and 15 gives me 30, in this case 0.18. And so we end up with 78.18 square units. I didn't give you any units, so you just put square units as the answer. So 78.18 is what you should have come up with. This one's a pretty hard problem because of the fact that we had area, kite properties, Pythagorean theorem, trigonometry. We've got a lot of stuff going on in this one problem. Okay, so there's a lot to it. Hopefully you were able to kind of work your way through this. Any questions in terms of anything not make sense that we did? Okay, so there's the warm-up, and I really like this warm-up because of all of the stuff that we had to do in order to get a final answer. It takes you back through a lot of different things that we've talked about. So now what I want you to do, go into the lesson, 733 lesson in your ebook. We're going to kind of do the first problem together, and then we're going to we'll do the second part together as well, and then we'll go from there. And we'll see what time is left and where we're at that point. So 733 is almost like a review. It's kind of like your final section of the chapter. And notice it says today you're going to use algebra tools to investigate properties of quadrilaterals and then use those properties to identify what you have. So it's similar to what we've been doing. They're going to give you like 4 coordinates. Say plot the points, connect the dots, and tell me what it is. We're going to do the same stuff we've been doing. Matter of fact, I put it over on the sideboard. If you take a look, we're going to find the slopes of all 4 sides. We're going to find the side lengths. Then based on those 2 pieces of information, you're going to tell me, what do I know? Do you have any parallel lines? Do you have any perpendicular lines? Any sides that are congruent? And then based on that information in step 3, you should be able to tell me exactly what shape we're dealing with all of the mathematical proof. Okay? To give you a quick heads up, so some people in the last class said they would go through and they'd graph something and be like, oh, that's a parallelogram, that's a rectangle, and I said, well, how do you know? They're like, well, I just looked at it, it is. Part of what we're doing, I told you before, we're not necessarily doing actual 2-column proofs or anything, but now, if you're going to tell me that something is a shape, you have to have the mathematical proof to back it up, which are slopes, side lengths, parallel lines, all that kind of stuff. You got to be able to back up whatever you're saying with mathematical proof. So we'll talk about that today as well. Let's take a look at this first problem. Must be, could be, kind of a quick review here. If I've got a quadrilateral that has 3 right angles, what must it be at least? Thinking back to your quadrilateral properties. It's got to be at least what shape? 3 right angles. What do you think?
Rectangle?
It's got to be at least a rectangle. And really, realistically, if it's got at least 3 right angles, how many right angles does it actually have? Yeah. If it's got 3, it's got 4. Because remember, the 4 angles have to add up to 360. There would be 90 degrees left to get you to 360 at that point. So this one would be at least a rectangle. And what else could it be? Could be a square. Could also be a square. So there's your options on that one. If you've got a shape that has 3 right angles, it's got to be at least a rectangle, could also be a square. All right, how about part B? Quadrilateral that has a pair of parallel sides. What is it? Got to be at least a trapezoid, okay? 1 pair of parallel sides. At least a trapezoid. What else could it be? Parallelogram, rhombus, rectangle, square. Anything that has more than 1 set of parallel lines could be any of those, okay? It has at least 1 pair. It could have additional ones. So the could be are all those other ones, okay, all the other options. Part C is a little bit tricky. Let's see what you come up with on this one. If I've got a quadrilateral that has 2 consecutive equal angles, remember the word consecutive is one right after another, okay, 2 in a row. So you have 1 set of congruent angles, 2 consecutive equal angles. What do you think? This one's a little bit tricky.
It might be like a trapezoid.
Close.
Or right.
Could be a right trapezoid. Yep. In this case, when it says two consecutive equal angles, could actually be an isosceles trapezoid. Okay, but you're absolutely in the right category of a right trapezoid, isosceles trapezoid. Could be a rectangle, 90-degree angles has that. Could be a square. Okay, again 90-degree angles. But it starts off in that concept of trapezoids. And right trapezoid, isosceles trapezoid. That's the starting point. Okay, here's what I want you to do. Here's the plan for today. You have basically 3 problems. We're going to see how many we can get through. What you're going to do is they're going to give you information. They're going to give you a quadrilateral in each one of those 3 problems. You're going to graph either the points, or in part A, you're going to graph the lines. And then you're going to do the stuff that I put on the sideboard. What are the slopes of each side? What are the lengths of each side? What do I then know? And we're going to kind of put that together. And that's where the other page that I gave you today, that's where this is going to come into play. We're going to kind of quickly do part A together. Okay? And then from there, I'm going to let you do B and C on your own, and I'll answer any questions that you came up with. So let's go to that extra sheet then, and let's actually go through and start to graph this and see what we have. First question: how do you graph a line? Going back to this is some of the basics of Algebra 1. What do we do? And if I'm looking at this one right here, how do I graph that? What do I do first? Lena?
Graph the y-intercept.
Yep. Anytime, you always start with a point and then use the slope to find other points. So the y-intercept is positive 3. So on the y-axis, I'm going to put that point. And then from there, I use the slope of negative 3 halves. I'm going to go down 3 and over 2 to find some other points. So here would be another point on the line. I could go again, down 3 more, over 2. There would be another point. I could go up 3 and to the left 2. There would be another point. Okay, but ultimately, start with the y-intercept and then use the slope to find other points. And now we're going to draw a line in. Don't forget to draw a line in. Not the greatest line ever, but you get the idea. So there's our first line. All right, let's go to line number 2. Only difference, they changed the sign on the slope, they changed the sign on the y-intercept. So now we're down here at a minus 3 for my y-intercept, and I'm going up 3 over 2. There's another point. Up 3, over 2 more. There's another point. And again, go ahead and draw the line in. There's line number 2. Line number 3. Up here at positive 9. Y-intercept. And now we're back again. Slope of negative 3 halves. So we are going down 3 and over 2. Down 3 more, over 2 more. That happens to be right there. And we'll draw that line in. And finally, let's go to purple here. Positive 3 for a y-intercept, up 3 over 2, turns out to be that point, and we'll just draw that in. So which quadrilateral are they talking about, by the way?
I don't know. No.
Which quadrilateral are we looking at? They're talking about this one, right in the middle. This is the quadrilateral that you're looking at. Okay? And so here's the question I have for you. This was the point, like I said, where last class they were starting to say, like, all right, I know what shape that is. They just wrote the answer down and moved on. Okay? I can tell you, you will have a problem, not necessarily exactly like this, but these types of problems on the test next week, and you've got to be able to back up whatever you say with the math to prove it. Okay? So right now, let me take a look. What do you think this shape is? What would you predict right now?
Rhombus.
Okay? Yeah, it kind of looks like a rhombus. It's kind of got that parallelogram look to it. It looks like we're about the same. Yeah, no question?
Wait, is the green one correct?
think so. Let me take a look.
Oh, I didn't.
Up 3 over
I
2.
thought that there was a negative.
No, we're okay. I think we're okay. All right, so it looks like, Brady said it looks like a rhombus. Well, now here's where the math comes into play. Okay, if it's going to be a rhombus, I got to start looking at some of the different things. That's like I said on the side. So what I'm really looking at is 3 things. Do I have any parallel lines? Because that'll help me narrow down the shape. Do I have any perpendicular lines? Because that tells me if I have any right angles. And do I have any congruent sides? Okay, let's start with parallel. What do we know about parallel lines? Same slopes. Do I have any? Which ones? You can use the colors. Which ones?
Red and blue and then.
Yeah. Red and blue both have -3/2 as a slope. So those have to be parallel. Green and purple, +3/2. Those have to be Have to be parallel. Try that again. So I know that these 2 lines are parallel, and I know that those 2 lines are parallel based on the slopes. Now this one is given to you because you were given equations. Normally you're going to actually have to find the slopes, okay, when you're just given coordinates. So right now, tell me which shapes I can eliminate. What can this definitely not be? Can't be a kite, can't be a trapezoid. Kite has no parallel lines, a trapezoid only has 1 set. Those are automatically out. We're in that middle group on the back side of your toolkit. It's got to either be a parallelogram, rhombus, rectangle, or square. It's got to be one of those 4 shapes, just based on the parallel lines. So now let's go a little bit further. Still looking at the slopes. Do I have any perpendicular lines? Matthew, you say no, why not? How can you tell?
Because if there was perpendicular lines, there would be like a 2 over 3.
Okay? Perpendicular lines have opposite reciprocal slopes, meaning positive versus negative, and then when you flip the fraction, that's the reciprocal. So in this case, if I was going to have something that was perpendicular to the red line, we would have to have a slope somewhere with a positive 2/3. I don't have that. So in this case, if you just look at the slopes, there are no opposite reciprocals, which means I have no what? 90-degree angles. What other 2 shapes did I just eliminate?
Square and rectangle.
I don't have a square or a rectangle. Those are automatically out because I don't have any perpendicular lines. Okay? No right angles. They're gone. So the slopes have narrowed it down from basically 6 shapes down to 2. This has got to either be a rhombus or a parallelogram. Okay? Has to be based on what we've talked about so far with the slopes. And so to differentiate between those 2, here's where the side lengths come into play. And so, refresh my memory. How do I find the length of these sides? What do I do? How do I find the length, for example, of, if I was looking, how do I find the length of like this side right here? What would I do? What is it? Somebody said it. Okay, yeah, we put in a slope triangle. So if I go through and we take a look at that, let's say I put a slope triangle in there. That's 2, that's 3. And now I can use Pythagorean theorem to find that side length. Okay, yeah, Del?
So as long as you have like the slope triangle with the same, like, the sides going out with the same numbers.
Yep.
Couldn't you technically find from there that?
Say that again. Just
Like- So, say you go across and you do the triangle on that side, you know what I mean, like on the opposite side.
okay.
Technically, couldn't you just find it by noticing that there's 2 and 3 on that side?
You're saying so they have the same slope triangles?
Yeah.
Yeah, so if that's the case, like in this case, what I would want you to do is actually find the length of that side. Do the Pythagorean theorem. But then, what Adele's getting at is if you have any other slope triangles that have the same pieces, then you don't have to redo the Pythagorean theorem again. That's perfectly fine. You can just notice that, oh, I've got the same one, so it's got to be the same length. That's perfectly fine. So in this one, out of curiosity, somebody do that for me real quickly. What do you get for that side length? 3.61? Okay. So if you do the Pythagorean theorem, that length is approximately 3.61 based on Pythagorean theorem. And now here's what Adele is getting at. Let's say I'm looking at this slope triangle right here. Notice 2 and 3. It's got the same 2 pieces, which means we don't have to do the Pythagorean theorem again. I automatically know that that's 3.61. Then you come over here. 3 and 2 for that side. Same two pieces of your slope triangle. That side's congruent. And same idea here. 2 and 3. So based on that, since they have the same slope triangle for all 4 sides, you know that all 4 sides must be congruent to each other. And therefore, now, mathematically, what shape does this have to be? This is what? This is a rhombus. So Brady said he thought it was a rhombus to begin with, and now we have mathematically proven that it has to be a rhombus. 2 sets of parallel sides, 4 congruent sides. That's a rhombus. That's the definition of a rhombus. Okay? Does that make some sense? Get the idea of what we're looking at? And that's kind of why I put that on the sideboard over there. So what I want you to do then is now, that's the idea. Slopes and side lengths. Now I want you to do the next one. Okay? You do part B. Plot the 4 points. And now work your way through the process and see what you come up with. Okay? I'm going to turn you loose and let you work. If you have questions, I'll check on you and see where you're at and go from there. So ask if you need anything. All right, let's go to work. Go ahead and do that one.